Okay, hello. This is Mr. Ng again, back with question 8. Right, a student throws a ball vertically outwards. So once the ball is thrown vertically outwards, the student's hand is no longer on the ball. Right, so the ball is actually on its own. Right, we can say that only weight acts on this ball, and this is therefore a free fall question. Right, the sequence below describes the motion of the ball. Okay, the ball leaves the student's hand at t equals 0 with velocity of -2. Alright, so you can see that this point is already plotted on the graph for you nicely as P. Okay, it rises in the air until it reaches the highest point. Alright, here actually probably we should try and figure out what's the positive convention already, right? So number one, you can see that it leaves the hand at -2, right? And I know that this ball is actually going vertically outwards, so I will try to draw the ball's motion first, right? So the ball is here, right? It's going outwards, and I call this -2 meter per second, right? So what does this mean? Where's the positive convention? The positive convention must have been down positive, because I know the ball is going up, and I assign this upward motion to be -2, which means that positive convention must be down. Therefore, up is negative. All right. So I already know this, right, based off this statement and this statement. Can you see that? The parts are underlined, right? It rises in the air until it reaches the highest point. So nothing surprising there. All right. Then when it comes down, it falls and hits the ground with velocity of 4 meters at t equal 0.6. Now, the reason why I'm going to suggest that when it hits the ground, right, is somewhere lower, is primarily because if it hits the ground at the same point where it leaves the hand, right, then it will be somewhere here. And I will guess that the velocity here will be 2 because of no loss of energy, right? But because my velocity here is actually higher in magnitude than this one, or the speed is higher, I'll expect that this distance traveled is higher than this one, right? This one you get used to it a bit more later on when we discuss in more detail about energy, things like energy, and then you understand this a little bit better, right? So anyway, I hit the ground with a bigger velocity than when I left off, so that means I probably hit lower space, and the velocity is positive, which coincides with my positive convention, right? It makes sense now, right? Because this is positive because my positive convention is down positive, and I expect that this is moving down, right? It touched the ground for a very short time, all right, and then bounce up. So when it bounce up, it'll bounce up with a certain velocity here outwards, all right, and then it carries on moving up, right? And somewhere up there, I'm not sure exactly where, but somewhere up here, the velocity is -1, and the student catches the ball, all right? So what velocity would this be? I don't know, but I know this number is definitely bigger than -1, right? Because as I'm going up, my velocity should approach 0, right? I'm slowing down, remember that, okay? So what's represented by the gradient of velocity time graph? Okay, acceleration. All right, I think the standard answer given to you was 10 meter per second square. Okay, please note that the answer is not correct. All right, to answer this question, the correct answer is actually acceleration, right? Because they just want what is represented. So the answer is acceleration. If they ask you for the magnitude of the gradient of the velocity time graph, then the answer will be 10 meter per second squared, right? So draw the velocity time graph from 0 to 0.8. Okay, initial velocity is marked as point P in the graph, right? Like I said, we know that in this motion, free fall, throughout everything here, with the sole exception of the time where the ball is in contact with the floor, right? Everything here, the A is downwards and 10 meter per second squared because it's in free fall. Okay, so I say again, the whole motion is free fall except when the ball touched the ground. Because when it touched the ground, there's another force, right? The ground will push the ball up. That's how the ball can reverse direction here, right? So that's the sole exception. Everywhere else, this free fall, this free fall, this free fall, this free fall, free fall, free fall, free fall, free fall, right? Once I lift off the ground, actually I'm free fall as well, okay? So everywhere in the graph except when I touch the ground, my gradient should be 10, and in which direction? In the positive direction, because my acceleration I know is down and my positive convention is down. So I know my acceleration is positive 10 almost everywhere in this graph. All right, that's what I understand to be the case right now. Okay, so I look at this one, I try and plot this on the graph also. So this is the point where I'm interested in. All right, so we already know almost everywhere my gradient is 10, right? Actually, the line looks something like that. You can go and check this gradient. This gradient is actually 10. Right, later on, I catch the ball at 0.8 and -1, which is somewhere here. Right, I know that here I touch the floor for a very short period of time. Alright, and I know that the direction of my velocity must change, right? From +4, which is here, to some negative number that's probably higher than 1. So I will anticipate somewhere here, because I know that later on then I become -1, right? So I anticipate that the line carries on somewhere in this region, but where exactly I don't know. However, remember my argument earlier, only when I touch the floor, I'm not in free fall. Means everywhere else the gradient is 10, right? So I actually try and draw a line parallel to this, attached to this point, like that. Okay, and then I realize that this is the point where I hit the floor. Alright, it's perfectly fine if you draw this one a bit slanted. Maybe you draw a bit slanted like that, it's also okay. Right? But what you need to realize is this final part of the graph. How do you draw it? You know the point where the girl catches it, and you also know that the line here, the gradient must be 10, right? Because once I lift off the ground, I know this is free fall again, and free fall is always characterized by acceleration of 10 meters per second squared downwards, right? So I know it's a line that looks like that. Okay, so this one needs to be drawn parallel to this. Okay, Ken, mark the letter X, the point which the ball reaches the maximum height. We already know, we discussed maximum height a lot already. Maximum height is where the velocity is 0. Where is the velocity 0? Here. Okay, so this is where X is.